Welcome to NJP Online Mathematics. Do you know the tricks for solving this problem? For finding the first derivative, also known as the y over the x of this equation? Please, let's do it together. Here we are given the sine inverse of the whole of this, and we are to find the first derivative. So let's give the solution to this problem. We are given that y equals the sine inverse of the whole angle 3 all multiplying the sum of x terms of arrow, which ranges from arrow equals 1 to arrow equals x minus x squared divided by 2 as the angle. So we have to find the first derivative of this problem here. So we have to consider the angle. First of all, we are considering the sum of the x terms of arrow, which ranges from arrow equals 1, that we have to find the expression for the whole of this. And if we consider that, which we have the n terms, the sum of n terms of arrow, when arrow ranges from arrow equals 1 to arrow equals n, that this can also be written as n multiplying n plus 1 all divided by 2. Therefore, if we say that these two problems are the same, we can clearly see that the difference here is x and n. Therefore, x equals n. So where x equals n, then we'll be having that the whole of this, where arrow equals 1, as the range becomes x all multiplying x plus 1 all divided by 2. And this here can further be simplified to be x squared divided by 2 plus x divided by 2. So we can substitute the whole of this into this problem. So we have to consider this as the first condition for simplifying this problem here. So since we have obtained this to be the first condition here, we have to substitute it back into the equation. So in the equation here, we are having that y equals the sine inverse of 3 multiplying the whole of this, and this have been simplified to be this. So we are having x squared all divided by 2 plus x divided by 2 minus x squared divided by 2. So we are having this finally. So we can see that in this problem that we are having here, that this and this, they are common, and since they are common and this is subtracted from this and they are the same, then we are having that y equals the sine inverse of 3 all multiplying x divided by 2 as the angle for the sine inverse. So if we continue, we are having that y equals the sine inverse of 3x divided by 2. Therefore, we can let the angle 3x divided by 2 to be a. So we have this as the first equation. So if we substitute it into this that we are having, let's call this the second equation. So we'll be having that y equals the sine inverse of a, and from here let's call this the third equation. From here we can say that A equals sin y. A equals sin y. Therefore, if we try to continue differentiating, we'll be having that dA all over dy equals cosine y. So we are having this because if we differentiate sine of an angle, let's call it x, then we'll be having the cosine of the angle x. Therefore, after we were having sin y, we differentiated it and we are having cos y. So now that we are having cos y for this, and we are asked to find dy over dx, that means the dy here must be the numerator. So for us to turn this to be the numerator, we have to take the inverse of both sides, the reciprocal, that is dy over dx, dA equals cosine inverse of y. So we are now having this, and this can further be simplified to be dy over dA equals 1 divided by cosine y. Therefore, from here, we have to remember the identity for the cosine and sine of angle, that we are having cosine square y minus sine square y, that this equals 1. So since the cosine square y minus sine square y equals 1, we have to eliminate off to find cosine y from this equation. Cosine y here will now become cosine y equals 1 plus sine square y. So we are having this as the result for cosine y. So let's substitute this. We have to substitute this here. So substituting it there, we are having that dy all divided by dA equals 1 divided by the root of 1 plus sine square y, the whole root of 1 plus sine square y. We still have to remember the condition where we said that sine square y, sine y here, that sine y equals a, and since sine y equals a, we have to substitute a back to this point. Then we'll be having 1 divided by the whole root of 1 plus a square. We are now having this finally as dy over dA. So we have to keep this as an equation, which we will return back to. Further, we need to remember that we said that 3x divided by 2 equals a. Since 3x divided by 2 equals a, this equation can also be written as a equals 3x divided by 2. Now we have to differentiate this equation. If we differentiate this, we are going to have that dA all divided by dx equals 3 over 2 x raised to the power of 1 minus 1. We have just multiplied 1 by the whole 3 over 2, and we are still having 3 over 2 as the result. Thus, we are having that dA divided by dx equals 3 over 2, and this, the whole of this is the same thing as x raised to the power of 0, which is 1. And when this whole multiplies 1, it becomes this same fraction. So we are having now that the a divided by the x equals 3 over 2. But we need to recall from the identity that now with that we are having the a, we are having the y, and we are having the x using quotient chain rule, that we'll be having the y all over the x is the same thing as the y divided by the a multiplied by the a divided by the x. Recalling from this chain rule here, we have to substitute the problems, this and this, into this equation here. So we are having that the y all over the x equals the y over the a. The y divided by the a is the whole of the inverse of the root of 1 plus a square. So we substitute it here, and we are having 1 divided by the root of 1 plus a square multiplied by the a over the x, which is 3 over 2. 3 over 2, and we are having that 3 divided by 2 the root of 1 plus a square. But we have to take note that a square was a variable we substituted for the whole of 3 over 2x. So we have to substitute 3 over 2x in place of a back into this point that we are having, that 3 divided by 2 multiplied by the root of 1 plus a square equals the first derivative. So this becomes 3 divided by 2 to the root, multiplying the root of 1 plus 3x divided by 2. Therefore, the derivative of the initial equation that we were given, which is this becomes 3 divided by 2 multiplying the whole root of 1 plus 3x divided by 2. So this becomes the final solution of our problem. Thank you for watching. Kindly like and subscribe.